Hey folks. Okay, this time I want to get into a little bit of discussion about how to use Makefiles and how to write Makefiles. It's not something I'm going to require you to do a lot this semester in terms of writing your own Makefiles, but we will be using them a fair bit and it helps to understand what's going on. So, let's to dive into this a little bit. Our C++ programs can be made up of lots of different header files and .cpp files, right? So you could have 3, 4, 10 different files that all get compiled together to create your final executable. Now, quite often we're going to find that we make a change to one of those files and then need to recompile our executable. We typically don't need to recompile all of the different files to include the update that we've just made. Usually it's possible to recompile just the correct subset of files. And so one of the ideas is we would like some way to automate the process where, suppose I've got a program that uses 50 different files. If I edit one of them, I want some way of automatically just recompiling the things that need to be changed to create the new up-to-date executable. This gets especially important when you start dealing in teams where you're working with multiple people. You want to make sure that we've got some ways that if any one of us happens to modify a file or a couple of files, we recompile just the right subset. So if you're working with an integrated development environment, some kind of a development tool, in all likelihood, this is carrying out that process for you. You edit something, it automatically recompiles the right set of files to produce your new executable. But behind the scenes, it's going to be doing something very similar to what we're about to look at with our Makefiles. So the Makefiles provide us with a way of providing a set of rules that says, if this file changes, this is what needs to be recompiled to build our new executable. So I'm going to play with just a simple code example first and play with using a Makefile to show what happens, or hopefully what's going to happen. And then we'll get into the actual mechanics of writing a Makefile. So let me just get an example up here. So in this case, we're going to have a program that's made up of 4 different files, 2.h files, array.h and myprog.h, and 2 CPP files, array.cpp and myprog.cpp. And we're going to compile those together to create a program called myprogx, an executable named myprogx. And the Makefile here is going to have the instructions on what actually needs to be recompiled when. So let's just take a quick look at the contents of these files first. So the header files contain definitions for data types, constants, and functions that we're going to make use of in our programs. So if we take a look at array.h here, array.h has a struct that defines some information for a float array. So in this struct, it's going to have the actual array size, how much of the array we're currently using, and a pointer to allow us to dynamically allocate an array of a specific size. So our array.h has the definition for the struct, and it's got 2 functions. One to go through and allocate an array where we call it, we pass it one of these struct variables, a float array variable, and a size that we want, and it's going to go through, try and allocate the array, and return true or false based on whether it worked or not. So it's going to go through and fill in the fields of the struct for that array item. And then we'll have another function where we pass it our float array again, and it just goes inside, takes a look in the struct and deallocates the array if there was anything there. So just 2 simple functions. And again, the header file gives us the profile for those functions and the data types that we're going to use, but it doesn't give the implementations. The implementations of the 2 functions are going to be in the array.cpp file. So in the array.cpp, we hash include that array.h using double quotes to indicate that this is one of the arrays file in our local directory. And we go through and include whatever else we want. And we go through and have the actual implementation of those 2 functions. So array.h and array.cpp provide us with functions that we can use for allocating and deallocating an array. And again, I'm not going to worry too much about the actual contents of those, just we'll save that kind of thing for discussion later. I just want to look at the use of the Makefiles for now. And then in myprog.h, we're going to have just a constant for an upper bound on how big an array the user's allowed to create with this program, and a profile for a function to get an array size from the user. So we're going to let the user pick a size from 1 to max, and then we're going to use those array routines to actually allocate it and deallocate it. So then in my myprog.cpp, we'll have our main routine. So it creates one of those float arrays, calls the getSize function to get a size from the user, calls allocate to try and actually create an array inside it. If that succeeds, then we'll say it worked, and usually we do something with it. But again, this is just kind of a toy example. So we're just going to go on and deallocate it, just to show examples of the calls. So in our myprog.cpp, we've got our main routine, and we've got the implementation of that getSize function. So in terms of how we get access to these things, right, the main myprog.cpp is going to include array.h because we're making use of allocate and deallocate, and it's going to include myprog.h because we're making use of the getSize function. So these includes say, okay, go look in these other header files for the definitions of these things, and then here we'll provide the actual implementations. So we've got this program that's divided up across 4 files, 2 header files with definitions, and then 2 .cpp files with implementations. And when I compile them together, I'm going to want to compile array.cpp, so I want to translate that into a .o file, so an object file. It's got the translation of just this file's .cpp code. And we'll have another one where we do a translation of just this file's .cpp code, just myprog.cpp's. And then we'll link those 2 results together to create the final executable. So I'm going to do this manually first. So if I do my g++ array.cpp, and I'm going to use wall and wextra to turn on all warnings and extra warnings. And then we throw in this -c flag to say, okay, this is what specifies we're just going to translate this one file into an object file. Just a bunch of machine code. It's not going to be a complete program. And we use a .o extension for that. The -c will automatically throw that in for us. So in theory, this compiled okay. So if we do an ls now, we'll see that it's created an array.o. And then we'll do the same thing for the myprog.cpp. And again, the Makefile is going to do this for us automatically in a moment. And things look good. So now it's created, where are we? My myprog.o. So far, so good. But these 2 files, again, are translations of the C++ code in those 2 files, but neither one of them by themselves is a complete program. So we have to link the 2 of them together. And again, G++ can do that for us as well. So I'm going to take the array.o and myprog.o and compile them together with my warning flags. And I'm going to specify that I want to create an executable named myprogx. And hopefully that works. Seems to work okay. Now we can actually try running our program. And it asks us for an array size, and I don't know, I picked something, and it worked. And so hopefully that went off and did the allocation and deallocation. But again, the idea is we just want to see that this compilation process works. Okay, I'm going to remove those files, and we'll show that the Makefile does this for us. So we type in make and the name of the thing that we want to create. So I want to make myprogx. And it goes through, and you can see it ran that same set of commands that I did. It ran the 3 G++ commands, to create the two .o's, and then link them together to create the executable. So this is the kind of thing that we want, but we also want we just want, if we edit one of those files, we just want to recompile the right subset of other files. For instance, if I edit my array.cpp, so I'm just going to stick in a toy edit there, and I do that same make command, hopefully it realizes that it's got to change the array.o file because array.cpp has changed, and it's got to change the executable because the array.o has changed, but it shouldn't need to recompile myprog.cpp into myprog.o. So hopefully, yeah, it realizes that it's just got to recompile those two files. Or similarly, if I was to modify myprog.cpp, then it realizes that it's got to recompile myprog.cpp and it's got to relink to create the executable, but it doesn't need to recompile the array.cpp. So this is the idea for our Makefiles, to get all this to happen for us automatically. So what we'll do next is to go into how to actually make that happen. All right. So the idea is, in the Makefile, we're going to put together a set of rules that say, under this circumstance, this is how you rebuild this file. So everything that can be rebuilt is called a target. So the .o files are targets, right? They're things that can be rebuilt, and the executable itself is a target. It's something that can be rebuilt. For each target, we'll provide a list of dependencies. And the idea is, if any of these files have changed since the last time we rebuilt the target, then it's time to rebuild the target. And then for each of those targets, we'll also provide a rule that says, okay, if you do need to recompile it, here is how. So all of this gets put in a file named Makefile, and then the make program looks in the current directory for a Makefile when you ask to rebuild something. So if you say make and some target name, it looks for a file named Makefile and then looks inside it for something that tells it how to rebuild that thing. And then within the Makefile, the way things are going to look, you can stick comments in your Makefiles, so just begin them with a hash. This is kind of like the single line comments in C++, right? Just a different symbol to start it off. And so for each of the rules in our Makefile, we'll have the name of the target, so the thing we want to rebuild. So let's say I want to rebuild myprogx, and then a colon, and then the list of files to look at. And if these things have changed, or if they need to change, then it'll go off and check the rules for those first. So for myprogx, I need to rebuild it out of myprog.o and stack.o, for instance. So this is a slightly different example than ours. Here, tell you what, why don't we actually look at the example we just played with, the Makefile we just played with, and comparable idea, different example. Let me pull that up. This might make more sense. All right. So we've got our array.h, array.cpp, myprog.h, myprog.cpp. We're building myprogx, and we've got our little Makefile that we want to take a look at here. So for our Makefile, if I want to rebuild myprogx, I need to check if myprog.o or array.o has changed, or if they need to be updated. So I list those as the dependencies. And then I give the command to say, okay, once those two things are up to date, this is the command that we use, the g++ command, to rebuild the executable. Similarly for myprog.o. Well, myprog.o needs to be updated if its .cpp file has changed, or if its .h file has changed, or actually if that array.h file has changed, since it's grabbing definitions from that array.h for the allocate and deallocate and for the float array struct. So if any of those three files have been altered, we should rebuild myprog.o. And again, we give the instruction for how to actually rebuild it. Similarly for array.o, right? If array.cpp has changed, we should update the .o file. If array.h is changed, we should update the .o file. It doesn't care about myprog.h because it doesn't use anything from myprog.h. So if either of those files have changed, then run this command to rebuild the .o file. So if we type in make myprogx, it goes in and says, okay, well, have either of these things changed, or do either of these things need to change? So it goes off to the rules for those. So for myprog.o, it says, okay, well, have any of these three things changed? If so, I need to do this to bring myprog.o up to date. And it goes off and checks the rules for array.o. Have either of these things changed? If so, run this. And then once that's done, it checks to see if either of those have been altered since, or been updated since the last time we updated myprogx. If so, run this command. And so this is the set of rules that dictate what make rebuilds and when. Now this little beast at the end, we can stick in additional commands to say, essentially to tell make that if I say make blah, here's what I want you to do. So these are called phony commands in that they don't have any dependencies. They just have some action that we want it to run. So for those of you who were in my 160 last term, you might remember that we used make to do some of the lab submissions, and this was the way that it was done. So if we do something like, for instance, that make clean, it runs the remove command that you saw at the bottom of that make file. And then since the .o files are now gone and the myprogx is now gone, if I run make myprogx, it's going to need to rebuild everything. And so we can go through and play with some of this stuff. All right, that was the biggest point I wanted to get there. So our make files have got a target, the things it depends on, and a rule for how to rebuild it. Now, one of the weird things about Makefile syntax is on those lines that have a rule to rebuild or a command to rebuild something, you will have noticed that it was indented when we looked at the file a few moments ago. That chunk in the front is actually a tab. If you have spaces in front, when you run make, it's going to complain at you about the syntax. So if we take a look at our Makefile again, that first character is actually a tab. I've got Vim set to highlight tabs this way right now, which is why it shows that kind of weird syntax. But all right. So odd syntax rule, but it's one that you get used to, and make yells at you if you don't have a tab as those first characters. So we need tabs as that first character. When we're using the make file, again, as we've just seen, you type in make and the thing that you want to rebuild. Now, in the example that I've been doing so far, I've always just rebuilt the executable, said make myprogx. If you wanted to, you could go through and simply say make stack.o. So any of the targets you can use if you specifically want to rebuild one particular thing. And again, make takes a look at it, sees if it's up to date or if it needs to be rebuilt, and then if it needs to be rebuilt, it runs the appropriate command. And again, as we kind of discussed it when we were working through that example, for the target that you've got, make goes through the list of dependencies, checks to see if any of them need to be updated, checks to see if any of them have been updated, and then runs the instruction for rebuilding that target if necessary. The way make actually decides if something is out of date or not is it just looks at the modification date for the target and the modification date for the dependencies. If the dependency has been updated more recently, then it's time to rebuild the target. Or for that matter, if the target doesn't exist yet, then make thinks, oh, it doesn't exist, I better build it. All right, so this is going through using our stack myprog example, which is pretty much just exactly what we did with our other example. So I think I'm going to skip through this for the moment. Again, if you're reading through the slides, this gives you an alternate way to go through and have a look at things. And this is just another description of that phony target, this idea that if I've got an instruction or a target that has no dependencies, I can stick in pretty much any bash or Linux command that I want on the next line, again with a tab in front. Say, okay, if somebody types in make clean, do this, this is what they want. So they're referred to as phony targets since they aren't really building part of our executables. Now, one of the things that's often done is if we've got multiple different executables in the same directory, then we'd have separate targets for each of them, right? Say I had my progx and some other progx and whatever else it was. Then we could, as a user of the Makefile, type in, make my progx, make other progx, that kind of thing individually. What's quite often done is to allow somebody to recompile all of them at once. So you'll quite often see all as a first target in a file, and then it'll list the name of each of the different executables. So if somebody types make all, it goes through and rebuilds all of them one by one. Now the other handy thing about make is that by default, if you just type in make, you don't type in make something, then it just picks whatever the first target is and rebuilds that. So if you make all the first target, then somebody can just go into a directory, type make, and it rebuilds everything in there. So this is one of the things that you'll often run across. Now, we've only barely scratched the surface of what Makefiles can do. I want you to be able to look at the contents of the Makefiles this semester. There might be times when you're going through and adding some of your own .h or .cpp files to the labs or the project, particularly the project this term, where you're going to want to know how to create your own rules, your own targets. So now we've got the ability to do that, but there's so much more that you can do with Make. You can build rules that take a pattern and look for file names that follow a pattern and use a patterned rule to rebuild them. We can use variables, there's if statements and things that we can use, and make all kinds of other things that we can do. And again, for most integrated development environments, this is the kind of thing they're doing for you behind the scenes, and it really helps to understand how it's working and how these things behave. All right, I will leave it there for now. We'll pick up with a little bit more on the C++ side of things next time around.